Hello there, welcome back to the Animation Hub. So it's going to be the 30-second session on Oracle Database Architectural Journey. We have been discussing log switch checkpoints and we did the hands-on to get the understanding on how it works. Now let's continue the next one, incremental checkpoint. Because we mentioned we have categorized the checkpoints into 4 categories: global checkpoint, log switch checkpoint, incremental checkpoint, and partial checkpoint. Now out of 4 we have spent 2 of them. So let's try to understand the third category, incremental checkpoint. Now you can see as the definition, flush only LRU buffers. Flush only LRU buffers from the buffer cache. So that's why incremental checkpoint means only the least recently used buffers. Only the least recently used buffers will get flushed. Not all the dirty buffers like the previous checkpoints, log switch checkpoint and the global checkpoint. So when you say all the dirty buffers, it consists of MRU and LRU, most recently used buffers as well as least recently used buffers both. But here only the LRU buffers will get flushed from database buffer cache to relevant data files. That means the least recently used buffers, that is buffers which are not pinged for a long time, like committed, not used for certain period of time, that's what. So least recently used buffers. Now when it happens, what are the conditions for incremental checkpoint to happen? We put it here. When it happens, we can see checkpoint parameter settings. Now this happens on certain parameter values. Then there's another condition. Every 3 seconds when DB writer writes LRU records to relevant DBF files. So let's try to understand the first one. Mttr, checkpoint parameter settings. Mttr means mean time to recover. Now incremental checkpoint take place based on these parameters. Let's check what are those parameters. Let me switch to the hands-on environment. Now if I just type the command show parameter mttr, it will show me a parameter called pass start mttr target. By default this is disabled. So this is one of the parameters. The value for this parameter is set by means of seconds. The other parameter, there are another 2 to 3 parameters. Let's take a look at those. If I just type log_check, you will see another 2 parameters. Log checkpoint to interval, log checkpoint timeout. Now by default, this has been set to 1800. That is log checkpoint timeout being set to 1800. That is, this is also in seconds. That is 30 minutes. So that's the default value for incremental checkpoint to take place by means of parameters. Now Oracle highly recommends to disable both parameters and assign a value to pass start mttr target in order to control the time of the incremental checkpoints. Even if you set a value, automatically it will override these parameters. But anyway, the best practice is to disable these parameters. That means you have to make it 0. We can just issue a command like this: order system set log checkpoint timeout. I can disable the parameter. Let's say 0. Another one is order system set. I can just set a value like this for pass start mttr target. Let's say we're going to set a value like 180, 3 minutes, seconds. So now you will see the values, show parameter, mttr. But we can't set a value like randomly like that. I just set a value for you to show how it can be changed. Those are dynamic parameters. Now you can see both are disabled and we have the value set to mttr target 3 minutes, and so now the incremental checkpoint will happen based on this parameter. Now how to set this value properly? That is known as calibrating Mttr. Or under co-tuning, we need to set the best value. We need to identify what is the best value for Mttr target. That is a tuning concern. We need to tune up the database in such a way for the checkpoint to incremental checkpoint to happen with proper time intervals, and it varies from database to database. We will discuss in more detail under tuning checkpoints and under tuning memory structures how to set this value properly. And for the time being, if you want to get more details in the documentation, now it clearly says, now this is 19C documentation, Oracle 19C database performance tuning guide. If you go down again, you can see they are explaining configuring the duration of cache recovery, pass start Mttr, mean time to recover. You can see they are telling the relationship between checkpoint. The foundation of pass start Mttr pole recovery is the pass start checkpointing architecture. Instead of conventional event driven, that is log switching, checkpointing, which does bulk writes, pass start Mttr occurs incrementally. So actually what they are telling here, because this log switch and the global checkpoint, those things are bulk write means it does global checkpoint. That means it's clearing the whole buffer cache. But incremental checkpoints, it is not doing that. It is clearing only the least recently used buffer. So that it will help for this checkpoint process to speed up by completing the gaps incrementally, time to time. So that is what they are telling, to set this value instead of allowing checkpoint mechanism to only depend on this global checkpoint mechanism. So we need to set the best time. It's a lengthy topic to discuss how to set the proper value to Mttr target. But let me just briefly explain. Now it's like this. Mttr means mean time to recover. Mean time to recover what? Mean time to recover if the instance crash. That is what it says. So from one end, this parameter is responsible the time it is going to take if the instance crash. If the instance crash happen, Oracle database will automatically recover the instance. System monitor and process monitor will work together to automatically recover the instance. DBA just has to come and type the startup command. But the problem is the time taken to recover the instance may vary depending on this parameter. Because if frequent checkpoint taken place means what? Now let's say, for example, I have set this pass start Mttr target to, let's say, 120 seconds, 2 minutes. That's what. So that means what? Every 2 minutes an incremental checkpoint happens. So that means I am maintaining a checkpoint queue of 2 minutes. 2 minutes. So within 2 minutes, all the computed data which are in the log file has been synced up with the DBF files, and it is updated in the control files. Now the worst case is if an instance crash, the length of the checkpoint queue will be short. It's not going to be higher than 2 minutes. The highest is 2 minutes, and it should be less than that. Because let's say if the previous checkpoint, incremental checkpoint taken place at 3 p.m., if the next checkpoint, incremental checkpoint at 3:02, if the instant crash happen at 3:01 at 1 minute past at 3 p.m., that means we are looking at 1 minute of a checkpoint gap, because the previous checkpoint has taken place at 3 p.m. So the crash happened at 3:01. We have to recover only 1 minute of a gap. Why? The reason is we have said the incremental checkpoint happen every 2 minutes. So that's why it will shorten the recovery time. Because if there's a huge gap for the sync up to take place, let's say 10 to 15 minutes of checkpoint interval, we don't have. Now let's say if we haven't set the incremental checkpoint mechanism, what's going to happen? It will depend on this value now. For the incremental checkpoint, then it's going to depend on this one, the default value. What was the default value? 1800. That means 30 minutes. So every 30 minutes only incremental checkpoint happen. Then the recovery will be in trouble. Instant recovery will take long time. That is all. So that's why this particular parameter, this one from one end is responsible for instance recovery time. On the other end, it is responsible for incremental checkpoints. So that's why. So that's the basic understanding you need to know for the time being. So let's try to explain this one, how it works a little bit further during the last session of the architecture, during the component interaction. So in the documentation also is explained, so we can go through it. And the other one, the other method, so that's the first condition. The other condition is every 3 seconds, when DB writer writes, LR record to the relevant DBF file. Now every 3 seconds DB writer fires, no? DB writer fires every 3 seconds. So what is going to do? Least recently used record, it will update to the relevant data files in order to make some space, clean up some space from the buffer cache. So in that situation also, what's going to happen? An incremental checkpoint will take place. In an incremental checkpoint, it will update only the control file. Only the control file. It will not update the DBF files in an incremental checkpoint. So that's the difference between the pull checkpoint and the incremental checkpoint. Now in the documentation, that is also been explained in this place. Yeah, if you take a look at it, incremental checkpoint. An incremental checkpoint is a type of the thread checkpoint partly intended to avoid writing large number of blocks at online review log switches. That's true, we explained that one. DB writer checks at least every 3 seconds. That's what is mentioned in the document as well, to determine whether it has work to do. When DB writer writes dirty buffers, it advances the checkpoint position, causing checkpoint to write the checkpoint position to the control file, but not to the data file header. So that's why this incremental checkpoint will not update the data file headers. It will update the control file. When DB writer writes dirty buffers, it advances the checkpoint position, causing checkpoint to write checkpoint position to the control file. That's all. And in this case, they are mentioning dirty buffers, but it's not going to write the all dirty buffers. It will write the LR record, least recent used records. That is the other condition. Okay, great. So with that, it is, I think you got the idea about incremental checkpoints. I think we will do the partial checkpoint, the last type of checkpoint, on the next explanation. Great. Okay. Have a great time. Right. Bye bye.